Thank you very much. Good morning. So this is really an exciting era we're living in because so many other countries are getting involved in the exploration of Mars. This has gone on for a number of years, but each of these countries in the past have sent single missions, have sent missions where there's little or no international cooperation. But all that is changing significantly. So as you can see, the Soviet Union, the United States, Russia, after the fall of the Soviet Union, Japan, ESA, but now also India. And what's happening to the future of our international cooperation is we're beginning to work together on individual missions, more so than we ever have before. Today, we have a suite of operational missions at Mars. Mars Odyssey, Mars Express, Mars Reconnaissance Orbiter, MAVEN, Mars Orbiter mission, and just getting there in the next month, the Trace Gas Orbiter. These missions are our orbiters. On the surface, we have Opportunity and Curiosity still operating. Just a wonderful set of missions. What's coming up in 2018, we know that Elon Musk has said publicly there may be an opportunity for him to attempt a landing of his Dragon capsule. We're moving and working with Elon on those activities. And we have InSight, which is a NASA mission with plenty of international participation. And then as we look at the 2020s and beyond, we see now a whole set of missions that are starting to be formulated, built, and are moving forward for implementation. And there are others that are in pre-formulation right now that aren't even on this figure. So when we look at them, I can break these up with missions that have international partnerships. So I'm going to go through many of these missions and then sort of highlight what that international partnership is and what's come of some of those instruments. From a NASA perspective, NASA is leading a mission inviting international partnerships on the following missions: Mars Odyssey, Mars Reconnaissance Orbiter, Curiosity, InSight, and our Mars 2020 rover. So let me briefly go through these missions. Launched in 2001, Mars Odyssey began its science on February 19, 2002. The international instrument on this mission was the HEND instrument. This is an instrument that's looking for high-energy neutrons that are coming from an interaction with cosmic rays, which make it to the surface, as Jen mentioned, and the resulting high-energy neutrons give us an indication that that interaction is coming from water. So this particular instrument was important in terms of getting a sense for what regions may have water in thin layers in the very top soil. Odyssey also had a suite of wonderful instruments that look at various wavelengths that we interpret as mineralogy of the surfaces. And because we have landers, Spirit, Opportunity, Curiosity, we do what we call ground truth. We can make detailed measurements on the ground, compare them with observations from our orbiters that fly over, take other observations, relating those two and allowing us then to get an estimate of other regions on Mars with the similar spectral indications. Very powerful set of tools. Mars Odyssey is still working well. Another one that's really another spectacular mission at Mars for NASA is the Mars Reconnaissance Orbiter. This was launched in 2005, got into orbit in 2006, and so in the last 10 years of its operation with these instruments, and one of which is a high-resolution imager, has made a set of wonderful observations at Mars. The one instrument on this particular mission that's an international one is the Sharad. It's a radar, so it penetrates surfaces and allows then reflection at lower levels below the surface of Mars in certain regions, and giving us an indication, particularly in the polar caps, of the stratigraphy below the surface. Mars Reconnaissance Orbiter has done a whole suite of absolutely fabulous observations looking at surface layering and dust storms and diverse mineralogy and polar layering. And as you can see in the right-hand side, the stratigraphy of the polar cap that Sharad has really interrogated with this ground-penetrating radar. Number of fabulous observations. One more I want to point out, and as mentioned by Jen already, are these reoccurring slope lineae. There's 4 images that are stacked here, and each of these images of exactly the same region on Mars with our high-resolution imager on MRO called HiRISE are looking at these streaks over time, and we see them develop in the spring and summer, go away in the fall and the winter. And so as we look at a crater wall, which is the left-hand side of this image, and the top of the crater is on the right-hand side, you really get the fabulous sense of what Jen had mentioned about water perhaps percolating up, perhaps coming out of underground aquifers, perhaps being leached out of the atmosphere. There could be a variety of things that are happening here, and we still don't know the answer to those, and we're teasing that out. Curiosity, fabulous suite of instruments, but now we see a greater interaction with our international partners. From ChemCam, working with CNES in Spain, also with Russia, also with the Max Planck Institute in Canada, a whole suite of observations that are being made, working with our international partners and the instrumentation that's developed in many cases jointly between us and them. And just a few of the observations, and I know they've been discussed here before, but here's Curiosity sitting in Gale Crater, as Jen mentioned. Just below a thin layer of red soil, we see gray Mars, and when we take a good look at it, as she also mentioned, we see carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. In addition to that, the soil is moist and it has nitrates in it, which are also really exciting and important for us to understand its distribution. And of course, how the planet evolved in this manner, could it have sustained life, and also how we might be able to use these resources for sustaining humans on Mars. In 2018, to be launched, is what we call InSight. It's an interior exploration using seismic investigations, geodesy, and heat transport. It has a set of instruments, but 2 of the major instruments on InSight are international. The French space agency CNES has developed a SEIS instrument. This is the most sensitive seismic instrument ever built. Landing it on Mars and making those measurements will tease out what the interior structure of Mars looks like, and perhaps whether it still has a molten core or not. We're going to look at using a heat probe, that is shoved into the ground several meters. This is this HP3 instrument built by the German Space Agency, DLR, and seeing how the planet's heat is actually radiating through the planet and out through the surface, and getting us a sense of combining that set of suite of information to really understand the interior structure of Mars. Coming up also is the Mars 2020 rover. It's important that Mars 2020 rover goes to the right site. And as I mentioned earlier, we're trying to figure out what that is. We have a series of candidate sites that we're looking at right now, But when it's there, we want to go to an ancient habitable environment where life might have existed in its past. Ancient life, core rock. And the kind of cores that we're making are like a piece of chalk. I know we don't use that in classrooms anymore, but as I look out, many of you probably have experienced using chalk on chalkboards, and that's the kind of size and length we're talking about. They'll be encapsulated, laid on the ground. We'll pick them up and bring them back in the future for further analysis in the laboratory. As Jen mentioned, some of the exciting things that Curiosity is measuring can only go so far. It leads us then to wanting those samples so that we can take the next steps and really looking for biosignatures. And by bringing samples back, we'll be able to do that in our own laboratories. Quite a set of instruments that are on it, the French are involved in a LIBS instrument. This is going to do a laser zapping of rocks, and that's called breakdown spectroscopy. We take a spectrum of the result of that, and that enables us to understand the mineralogy in addition to doing some of the imaging associated with zapping the rocks and the surfaces. In addition to that CNES instrument working with the Los Alamos National Laboratory, Spain is coming back on Mars 2020 in a similar way as they did on Curiosity with more environmental monitoring. This will be temperature, humidity, wind, solar radiation, and in addition to dust. The Norwegians are going to be able to develop and deliver a ground-penetrating radar. Now, unlike Sharad, which can look down kilometers, this is going to be a much more shallow radar that will tell us exactly what the stratigraphy underneath the soil looks like, perhaps even detecting or finding close underground aquifers. We'll go down to about 500 meters in depth. The next set of missions I want to talk about now are the foreign Mars missions. And in each of these, there is a number of international connections, and they're only getting stronger over time. ESA has a Mars Express mission launched in 2003, got into orbit in 2003 at the end of the year. It also launched the Beagle 2 lander, which unfortunately did not survive and actually turn on and be useful on the surface, but we have found it. The Mars Reconnaissance Orbiter is found, orbiter with HiRISE is found where Beagle 2 sits on the surface. Out of the so many things that Mars Express has done, and we have an instrument on this that is looking at the charged particle environment, the solar wind, and its interaction with the ionosphere at Mars. But one of the things that this spacecraft does, based on its orbit, is about once a month or so, it has a pretty close approach to Phobos in particular, and it's imaged both Phobos and Deimos, and it's given us the most intense, the most high-resolution imaging of both of those objects. The moons of Mars, sometimes we refer to as the space station of Mars, and might play in a prominent role as humans go to Mars. So understanding these two objects are critically important. The Mars Trace Gas Orbiter launched in March this year, and next month it will be inserted in orbit on October 19th. It will launch another probe down to the surface. Now we have on the ExoMars Trace Gas Orbiter what we call a communications package. That's called an Electra, and it allows our rovers or any assets on the ground. Right now it's Opportunity and Curiosity. Soon it will be InSight, and all those will be able to communicate their data up through the orbiters and use the orbiters to send that back to Earth. And so the Electra package is critical for us and for ESA because indeed they're going to be landing a rover in 2020. The package that they put down on the ground called Schiaparelli will only last a couple weeks. It will make a variety of surface measurements, but it primarily is being designed to demonstrate that that their techniques are viable in terms of getting systems down to the ground and allowing them to then do their next mission, which is the ESA ExoMars Rover. And this is a fabulous rover. We are a part of one of the instruments, MoMA, which is the Mars Organic Molecular Analyzer, and it's going to then tease apart, extend the observations, as Jen was talking about, of these complex molecules, organic molecules, looking for potentially signs of life. The next really great step. Here's an overview of what's been on the surface before. You see ExoMars and Pathfinder, Viking, Opportunity. Here's where Schiaparelli will go, and InSight. So the three new ones in the next couple years, ExoMars, Schiaparelli, and InSight are shown. Mars 2020, as I mentioned, we haven't selected its landing site. But what you see when Jen talks about ancient Mars and the amount of water Mars had in its past, that would fit on this globe primarily in the blue regions. And what are the greens and the yellow regions are a little higher altitudes. That must be the ancient shoreline of Mars. Regions where water comes and goes, clays are formed, organic molecules have been found in mudstones and clays, and perhaps this is the mat so necessary to be able to start that spark of life and create complex biomolecules. By going to these regions, we hope to learn much more about seeking the signs of life on Mars. Also, India has just gotten into orbit, actually more than a year ago now, the Mars Orbiter mission called MOM. Great little mission, has a suite of instruments making imaging, both in thermal but in optical, also looking at solar wind interactions with the ionosphere and atmosphere. And the observations from MOM are being correlated with the NASA MAVEN mission. So this is really great. Here's some of the wonderful images of Mars that they have made and posted so far. Coming up also in the 2020s is the United Arab Emirates mission called HOPE. This is a mission that's like MOM and MAVEN. It's also one that will study the interaction between the solar wind, ionosphere, and atmosphere. Each of these have specific strengths associated with them. And if MOM survives, it may not, but MAVEN is designed to survive up through this time period, then HOPE observations and MAVEN observations could potentially be correlated together. Really a tremendously exciting time. Last year, China has announced a Chinese rover. We don't know too much about it. It's stated in the press that there are some international interactions and connections. This rover is going to be at either 2020 or 2022, as I remember, as the press releases have. So we're gonna take a look and see how this evolves over the future. So let me end again by summarizing. This is a fantastic opportunity for the world to work together, and we do that through the types of missions that I've discussed, and it helps us propel humanity forward in the exploration of Mars. And so more to come. Thank you very much. I do have a few minutes for questions. Looks like, yeah. Okay, good. There's some back here.
Oh, okay. 6 years ago, Congress passed a really, I thought, reactionary piece of legislation prohibiting you and other people from NASA from cooperating, exchanging information, working with the Chinese Space Agency. And I think that's terrible. That's terrible, because some people have suggested, well, the Chinese will steal our secrets for not sending a human expedition to Mars. Not sending one. We, of course, would not steal any of their information. But I think that I think that law has to be challenged by NASA and other space enthusiasts and supporters, and it has to be retracted, because if we're going to have international cooperation, and we need it, we certainly have to do away with that law, which prevents us from cooperating or even exchanging information with China, which is now apparently determined to begin a very serious and robust Mars exploration program. So I hope that law is challenged by NASA or changed, and that we can cooperate. See, China is cooperating with the European Space Agency and with Russia and everyone else but us, because we're not allowed to cooperate with them. That's it.
Okay, thank you very much for your comment. And let me mention a couple things relative to that, all right? Scientists work together, and that is, bar none, an internationally recognized. Even during the Cold War, scientists in the United States worked with Russian scientists. So peer-to-peer scientific exploration of Mars or any other solar system body by both Chinese scientists and United States scientists is going on. So even though there are restrictions, and there are different restrictions than we have with other countries, there is a fair amount of exchange of information, and there's always scientific exchange. So it's not as black and white as you make it out. So there's a variety of interactions that do occur over time. They are explicitly approved through the administration and Congress, and once those approvals happen, then indeed we start discussions with China and other organizations that are spacefaring.
Yeah.
Okay, so yeah, sure, you got the mic.
MRO is beyond its lifetime, scheduled lifetime. So the Electra package should handle a lot of the comms relay.
Correct.
But what about a replacement for high-rise? If MRO were to die tomorrow, wouldn't that severely hamper efforts at planning where the first manned site might be for landing and things like that? So have you programmed a replacement for MRO?
Yeah, really good question. So in this next decade, one of the indeed considerations are, as we clearly recognize that MRO will not complete this next decade in its operation, will be a replacement for a high-resolution imager. Okay? Now, whether NASA does it, takes that responsibility on, or one of our foreign partners takes that on and moves that forward, that's to be determined yet. And I hope in the next couple of years we'll be able to determine that. But your point is really well taken. MRO has been at Mars 10 years. High-resolution imaging could see that table, or half that table, easily if that sat on the surface of Mars. And in that length of time, it has mapped 3% of its surface. Okay? So high-resolution imaging is still of fundamental importance for operational and situational awareness of what's happening at the high resolution on the surface. What we are doing, of course, is right now, while MRO is still available, working hard to determine where humans will go to the surface. And in the next talk, you'll have much more information about that. Who's got the mic next? Yes, sir.
You're NASA, and you can work with pretty much whoever you choose, except for China.
No, once again, that's not true.
I'm a small business, and I can't even work with a co-researcher in the United Kingdom because of a law called ITAR. You're talking about international cooperation. When are we going to get this roadblock removed, or at least modified, so that the permitting process for that is easier?
So that's the same law we interact with. You know, we have to be very sensitive about ITAR. Every one of our missions have a well-defined interface document that has to be developed. We develop and deliver critical instruments with great technologies associated with them to a variety of missions. Those are put on and launched. NASA does indeed have extensive experience working within the legal framework of ITAR. And so I would encourage you to get more information about how we do that, because it's been successful. For us, because we work within the framework of the law. But, okay, so you're telling me you can't do it, but I'm just telling you NASA has done it, and I think there might be an exchange of information that could help you, and we could start that dialogue to see what that would be.
To what extent does NASA... Hello?
Here.
Oh, yeah.
To what extent does NASA plan to include international cooperation in the manned missions when we eventually do go to Mars?
So indeed, space station is one of the most international aspects that NASA works in that environment. That's astronauts from a variety of countries living and working on space station. That model is going to be moving forward. NASA will be using that model as we go to Mars. You can just bet on that.
So would that include the first astronauts to go there to be an international crew rather than a purely American crew?
I would say yes.
Hi, Antonio Gomez.
Okay.
Back in when I was in 4th grade, I used to skip school to go home and watch the launches of the Apollo. And back then there was the space race, or so we were told. I couldn't understand politics even less then. Are we now looking at a new version of the space race, which is maybe called cooperation or?
Yeah, the concept of a space race was all about who goes to the moon first. You know, whether, you know, you get your robots there first, orbiters there first, put humans on there first. You know, it's all about being first. We've really gotten over that. It's not necessary to be first in the sense of exploring Mars. It's really all about working together to determine what we can learn about Mars. And once again, I mentioned from a scientific perspective, the scientists exchange data, work together, publish papers, go to conferences, present those. And so the environment is very much an international and sharing environment. I don't believe I would classify the kind of things that we're doing internationally together as a race. It's not that at all. Okay? Yes. Final question.
How much more science and scientific knowledge of Mars will we understand with an actual human mission as opposed to these robotic missions? And what kind of things can humans do on Mars that robots can simply not accomplish? Thank you.
Yeah. So here's my perspective on that. Human exploration is not Star Trek. Okay? It's not go where no man or human has gone before. It doesn't work that way. Okay? So when we go to the moon, we had an enormous number of missions, did an enormous amount of science to be able to support human exploration and getting humans to the moon. Same thing is going on at Mars. So planetary scientists are leading the way to be able to answer a variety of questions that are so necessary for humans to be able to get down in the surface, live, work, and return. And that means we're also going to be with them as they deploy instruments, take data, and bring that data back with them. So that cooperation is really quite tight. Okay? Well, thank you very much.